Hey everyone, we'll just wait a couple of minutes for everyone to join. Hey Harsh, how are you doing?
Hey Amir, good. How are you?
Good, thank you. We'll just let everyone to join. I think
Yeah,
they're still getting started, so we can get started, I think, about 5 minutes.
sure.
Hey everyone, I think we can get started. We have already about 20-ish people that are joining us, and I think there'll be more that will also join throughout the session. So to kickstart, I'd like to introduce Harsh. He's joining us today from Gaia, so thanks so much for the time that you have taken to attend the session. We have some participants here today. They're wrapping about the week 3 of the program. Essentially, these participants, they've been very excited about the AI agent space. Some of them are, developers. The other ones are just early joiners that are just learning about the ecosystem and building their projects. So we're excited to, learn more about Gaia and understand what the ecosystem lies for all of the participants and beyond. And we also have the recording as well. So after the session, we'll post it on our YouTube, and then I'll also share it with you guys as well.
Perfect. Thank you so much, Amir. GM folks, thank you so much for joining in today. We're going to today look at how all of you can host your own AI, either be it on your local machine or rent a GPU online or anywhere, right? But you have full control over not just the AI, but also what data that you provide to the AI itself, right? With that quick little intro, also a note to all the note takers that have joined this call, please take good notes, right? Okay, let's get started. I'm Harish. I lead developer relations at Gaia. My primary job at Gaia is to help or showcase what Gaia is to amazing builders like you. And if you're not a builder, you will soon become one. You will see how easy it is to leverage Gaia and build on top of it, right? What are we going to cover today? We're going to cover a lot of things today. There is going to be absolute information overload. So I'm going to give you this disclaimer before I start the presentation itself. So don't blame me if there is information overload. All you have to do is refer back to this whenever you're trying to build something with Gaia or trying to use Gaia. We're going to cover what is Gaia on a very high level. I'll also show you what you get when you run something with Gaia, how you can customize and bring any open source model that is available today on the internet for your specific use case. I'll also show you how you customize this with your knowledge base, why local AI matters, and how it is important or different from using a ChatGPT or a Gemini or any of the cloud-based AI inference platforms, right? After that, we'll also go through a demo. A lot of this is going to be hands-on, so you can see and refer back to what I'm doing later when you are also building this. And at the end of this, I'll also show you how you can join the Gaia protocol, which is attach your node, which in this case can be an AI agent that you built to contribute inference to a Gaia domain. Don't worry, there are a lot of concepts that I'm going to talk about today, but I'll try to simplify them and explain to them to you all in such a way that it's easy for you to understand. I'm not going to talk any complex ML terminology today. I'm going to simplify it down to basic English, right? At the end, I have a lot of QR codes, so my request to you is if you have a phone, make sure you scan those QR codes, or you can obviously refer to this presentation later. I'll also send the deck to the team so that they can send it to you, right? With that agenda outline for today, let's jump into it. I have about, I think, 50 minutes. So let's make the best use of time and cover through all of this. This may feel rushed. If you feel it is rushed, don't worry. I'm also available offline if you have any questions on our Telegram group. I'll also ask the team to add me if there are any Gaia specific questions while you are building during the residency program, right? Okay, all you have to do is for me to know if you're listening or if you're not asleep is to keep reacting with a thumbs up on the call so that I know that you're all up and still awake and I've not put you to sleep right in the morning or in the afternoon, wherever you're joining from, right? So let's get started. How many of you react with a thumbs up emoji since there is no hand raise emoji? How many of you here today joining us have run your own inference locally already? Okay, nice. Not bad. Okay, awesome. Thank you so much for reacting. Let's go to the next question. Oh, wait. Oh, okay. All right, let's get started. I thought I had one more question, but it's okay. What is Gaia, right? While you read the beautiful creative that I have on the slide, Gaia essentially is a decentralized AI open source framework that lets individuals like you and me or any builders or even enterprises to run their own AI inference fully locally, scale it or monetize it, and also eventually run their own fully on-prem AI, right? How is this different from any existing frameworks, if you may ask? Gaia is decentralized. There are not many decentralized AI frameworks out today that let you have control over all the data that you're going to provide to the AI. instead of a black box where you drop in data and don't know what happens to it or how information is retrieved from it when you ask questions to it. Here, you have full control over how the AI will respond to you or which LLM you want to use based on your specific use case. I'll jump into use cases, explain how you pick a model depending on which use case in just a bit. And this is where I want to ask you how many of you have used an open source LLM before, not run AI locally, but just used an open source LLM like Llama or Mistral, Codestral from Mistral. Okay, amazing. Thank you so much for reacting. I can see all your thumbs up. Okay, so what is Gaia, right? The beautiful architecture diagram, but today we are going to focus only on this center part, right? Where this altogether combined is called a Gaia node, which is what you get when you install Gaia on your machine. When I say machine, you can run it on your laptop as long as it has at least 16 GB of RAM. If you're using a MacBook, 8 GB also works fine, but I'll tell you how to run a smaller language model if you have a smaller capable machine. Right. So what you have in the node is essentially an LLM that you can pick and customize. It can be a Llama 3.2. By default, you get Llama 3.2. You can also customize it to using Quen or Gemma from Google or Phi 3 Mini from Microsoft. Any model, right, that is out there. That as long as it is in the GGUF format, you can use it with Gaia. Then along with this, you also get a component called RAG, where by default, every node has a quadrant vector database. There are multiple vector databases which store information in the form of embeddings. I'll show you what this means. But you also get a vector database by default in the node. Along with this, you also get tool usage, where in some cases you would want to call a real-time API, right? Let's say you want to get real-time crypto prices, or you want to do real-time trading based on how much amount you have in your wallet, and AI decides for you to trade on chain. You can do that today using this architecture, right? Along with this, you also have an embedding model. While large language models are designed to generate output in the form of text or image or audio or video, embedding models are only trained to generate embeddings. I'll show you what embeddings are, but all of this combined together is a Gaia node, and this is fully running on your machine through a platform, open source platform called Wasm-Edge. Now, to all the technical folks today joining in, Wasm-Edge is a runtime, lightweight runtime framework that lets applications to be run on edge devices. By edge devices, I mean your phones or your laptops or your machines or even Raspberry Pi, right? You can run Gaia on a Raspberry Pi. If you're launching a node with Gaia, you're called a node operator, as simple as that. What you can build is on the right side, right? Multiple nodes come together as Gaia domains, where you can scale infinitely with multiple domains and have decentralized AI contributing inference for your own knowledge that you bring, right? You can also have fine-tuned models created on top of this and all of these examples that we have on the right side. But today we are going to focus, like I said, on the centerpiece, right? I'm going to show you in code also where you can see this, how to customize and all of this as we progress further. Right, what you can build with Gaia, whenever you launch a Gaia node, what you get is a chat UI by default that you can quickly interact with and see how the AI is responding to your specific knowledge. Along with this, you also get an OpenAI compatible API, which in simple words means today, if you are using OpenAI's API using api.openai.com, you can replace that with your Gaia node URL directly, right? You don't have to create a new wrapper or create a new application to be able to replace your existing OpenAI based applications if you already have one. If not, you can build on top of the OpenAI compatible API that you get. You can also build decentralized AI applications where you can combine multiple nodes that are contributing inference and create an application that takes data from all of these nodes and creates an experience for the user, right? You can also create an AI agent marketplace type interactions where you can pick different types of knowledge providers from the network and create an interface for them. Also, you can extend these capabilities or build on-chain transaction-based applications. I have a couple of demos that I'm going to show you later, where you can launch tokens autonomously on-chain, right? That is also possible with the current infrastructure itself. The most common use case that we see is a digital twin, which is essentially a replica of yourself or a replica of a popular individual or a replica of your code base that you can use to help you write code or document your code in Cursor or Visual Studio Code, right? So these are some examples of what you can build, but these are not just limited. These are only few examples that I'm sharing today. But there are various other examples you can jump in and build on top of Gaia with. All right, let's jump into some basic concepts that you would understand before you start building or creating your own AI agent. One is embeddings. I'm sure many of you have already run LLMs and you know what embeddings are. While there is this complex looking diagram, embeddings in very, if I were to take the liberty to explain what embeddings are in very simple English terms, embeddings are essentially words or phrases converted to numbers, right? And these numbers have some significance, right? We'll get to that later when we try and understand how these are created and all. But all you have to know if you are a first timer to building an AI agent is you will need embeddings to be able to interact with an LLM, because that's what the LLM understands, right? So words or phrases converted to numbers is embeddings. And now all of these are stored in what we call a vector database. Like you have the typical traditional databases like MySQL or PostgreSQL, where you have or NoSQL, where there are no relational databases. Vector databases are where you store embeddings. Now, what is a vector database? Again, in simple English terms, imagine a shelf with multiple boxes. Similar words, let's say happy and joy, are similar words with similar meaning, are stored in the same box. Similarly, there are multiple boxes in the shelf. And whenever a user or you ask an LLM a question, what happens is the embedding model or the LLM goes to the vector database and tries to find the box where the similar words are kept and then weaves the story. All that is the LLM is doing is creating a story or predicting the next word that has to come in its response and creating a story out of it and giving it back to the user as a response, right? That's all the LLM is doing. And vector DB powers this to be able to happen while it stores the embeddings. Now, let's say you have a knowledge base. For the sake of simplicity, I'm going to say, let's say your protocol or your product has a developer documentation, right? Or has a GitHub repo. What you have to do is, as a knowledge base, all of this combined together is called a knowledge base. It can be in multiple forms, right? One is text, PDF, Markdown, CSV, right? All of these formats, you can definitely convert them into an embedding. What you have to do first is you have to chunk the knowledge base. Now, what is chunking? LLMs, all LLMs have a limited context size, right? By context size, I mean, if I don't give a pause and continuously talk without taking a pause, right, you will not be able to understand me after a point. Similarly, for LLMs, they only can understand certain context length of text or data, right? So you have to chunk your knowledge base first and then create embeddings for it using an embedding model. There are multiple ways to do it, automated ways to do it. There are online platforms where you can create embeddings, right? All of this is already available. So don't worry about doing all of this manually. There are algorithms to chunk your knowledge base based on what type of knowledge base it is. For code bases, there is a different way to do it so that the context is not lost. For text, there is a different way to do it. All of these are already available online. So don't worry about figuring out all of these by yourself. I'm only sharing this so that you understand what you will need to do before launching an AI agent, right? Once you have the embeddings generated using the embedding model, you store it in a vector database. In our case, in Gaia's case, what you get after doing all of this is you get a snapshot. Now, you will use this snapshot to give it to your node saying, this is my knowledge base, and you have to respond to the user's questions based on the content or information available in this specific snapshot. I'll show you how this works, but these are some little technical aspects that you would understand before we jump into the actual building of an AI agent, right? Okay, here is a quick node demo. You can scan this, or I will go through the documentation and show you how to build a node. This will take you to the page where you start building a node, right? If you've scanned this, let's move on to the next piece, which is, of course, demo, right? Let's jump into the demo, and I hope my demos work, and I hope you're all still with me. A thumbs up would create a reassurance for me that you're all still listening to me. Awesome. Thank you. Thank you so much. Appreciate it. I can see it. Okay. So the first step that you do is go to gaia.ai. And when you are here, you can see explore agents where you can where you can explore all the current agents that we have. Sorry, I think I clicked the wrong link. Let's see. Let's go to the home page. Let's go to explore agents, and here you can see some of the agents that are currently live on the platform that are built using Gaia. You can also chat with them and see how they respond, right? Some of these may not be working, just a disclaimer, but you can definitely see what types of use cases you can tackle with Gaia. You can create a coder agent which can generate code for you if you give a prompt asking it to create a calculator application or a landing page, right? There are multiple of those examples that you can try. And here is the chat interface that you will also get when you launch Gaia node, right? Let's see which one. Yeah, let's go to this one. This is an agent that is trained on elementary chemistry question and answers for helping students learn chemistry terminology in simple words, right? You can click start, and this is the same UI that you will also get when you're launching a Gaia node, right? That's the UI. And if you see, there is an API tutorial, which is the REST API that I was talking about. You can simply build applications using this agent itself, right? If you don't want to launch an agent, you can also use this agent. Let's go to our documentation where I will show you how to install a node. Installing a node is only 3 steps, right? First step is you install the CLI, which is the GaiaNet command, which you will use to run your agent locally on your machine. And after that, you run Gaia init. If you're able to see it, the second command is Gaia init, and the third one is Gaia start. That's all. Once you do this, what you will get is this URL. Right? If I quickly go to my terminal, I already have this installed. I'm not going to do it again because it will download the default Llama 3.2 model again, which is about 3 gigs, and I don't think we have so much time to do that. But once you install or run the first command, you will see this folder, right, in your home directory on your machine. And inside this directory is all the components that I mentioned, right? There is an embedding model. There is the large language model itself, right? Like you can see, there are multiple large language models where I'm testing out with different models as of today. Then there is Quadrant, which is the vector database. Then you will also see the dashboard, which is where the chat UI is coming from. Now, once you have all of this, all you have to do is GaiaNet start, and this should start the node for you. Now, one node can become an AI agent by itself, or multiple nodes can join a Gaia domain, and that domain can become an AI agent, right? So once you do GaiaNet start, what it does is it starts the node for you and gives you a URL. If you don't want a URL that you can interact with, you can always pass the local only command, which is also available in our docs, where if you pass local only, it will only run fully locally with localhost as your URL, where you can only interact on your machine, right? Others will not be able to use it, right? Once this is done, we should see the URL in about a few seconds. If you have any questions while I do this, feel free to drop them in the chat, and I will take them as we go along the presentation. Wait for this to start up. It should not take a lot of time. Only the download usually takes a lot of time. But once this is done, like you can see, if I zoom in a little so you can see better, this is the URL that you get when you run a Gaia node on your machine. This will also work locally, but I'll quickly open this up and show you what this looks like. This is where you can see all the information about the node, right? You can see what the system prompt is. It's a basic prompt. You can customize this depending on your use case. I'll show you how to customize the knowledge base also. This is the large language model that is running on this one. And then you can also see there is the embedding model that is running. You can also see the curl command, like I said. If you call this from the terminal right away, you can see that this will respond automatically. Remember, all of this is running from my local machine. Like you can see, here is the response. And this came from my machine, right? So that's how you use the API. And if you click chat with this node, you should see the chat UI, where you can customize the system prompt and talk to the agent that you just built, right? I'm using a model called Jan Nano, which is a very small language model that apparently is really good at doing tool calling. Now, in the world of AI agents and building with AI, there is a concept called tool calling or function calling. And one of the more recent ones is MCPs. What these are is essentially this node that we just launched by default can only respond to based on the information that it has or the knowledge base that it has been provided with. For you to be able to get the most latest news or search Google for the latest results on a specific topic, or get the latest crypto price, or get the latest weather, or get the latest data from your platform, what you have to do is you either use tool calling or MCPs to be able to fetch this data, right? For that to be able to happen, you will need tool calling models. Not all models have tool calling enabled. So you have to look for the tool calling models. So this model that I'm showing to you today is enabled with tool calling by default. Now, where will you find these models, right? You can come back and ask me, Harish, come on, take a pause. Where can I find all these models? All you have to do is go to huggingface.co/Gaianet. All these links are also available in the presentation. If you scroll down, you will find about 218 models that we support today. And any model that has the name tool in it means it supports tool calling, right? Let's search for tool. These are the models that you can use. This one is a smaller one that can run on about 16 GB machine on a MacBook. 70 billion requires at least 24 to 32 GB RAM or a GPU based machine, right? You can run all of this on your personal laptop, or you can rent a GPU and do the same steps, right? All you need is Linux. If you're on Windows, you will need to install WSL first. That's the first step before you're able to run all of this, right? We don't support Windows natively yet. So this is where you can pick which model, right? Depending on which use case, right? If you were to ask me what would I recommend for text generations, you can always use Llama 3.2 or Gemma. They're really good. If you're building a healthcare based product or healthcare based applications, MedGemma is good. This one is from Google, the one that I'm showing on the screen. If you're building an application where you want code to be generated consistently, you can try using Quen or CodeStrel by Mistral. Quen 3 is a good model for generating code. But my recommendation to you is, based on your use case, try multiple of these models and see which one fits the best for you. That's how you pick a model. Now, once you pick a model, like you saw, I'm using Jan Nano here, right? How will you be able to customize this? Let's look at customizing the node now, depending on our knowledge base, right? Along with models on our Hugging Face page, we also have data sets that you can try out, right? We have Paris data set, we have a Rust-based data set, we have chemistry data set. You can pick some of these to try out, or you can also go to my profile, where I have also added a lot of these data sets. Some of these are developer documentation. Some of these are digital twins of famous people, where I've created embeddings from their books, right? Or from some of the popular books, right? You can go to these and pick the snapshot URL. If you go to files and versions in Hugging Face, you should see a snapshot URL, right? You can just simply click on this, copy this, the download link, right? Now you go back to your terminal. Let's now look at how to customize this. Let me clear this so you can see better. How to customize this is all through one single file called config.json. Like you can see, config.json is where all the information about your agent lives, right? Agent has a wallet address. Agent also has the URL of the large language model. Agent also has the embedding model URL. If you want to use a different embedding model, you can do so. Agent also has something called a snapshot. This is where you have to drop in the snapshot URL that you created for your vector database. Now, how do you create a snapshot for a developer docs, right? Very simple. Let's say you have a markdown file or a text file, right? All you have to do is go to our documentation, and if you scroll down, there is a section called knowledge bases. Now, inside the knowledge bases, you can see there are multiple different tutorials for text files, markdown files, CSVs, and PDFs. Simply follow this, and once you follow this, by the end of this tutorial, you should be able to see a snapshot, right? All you need is that snapshot URL. And we're also working on interfaces where you don't have to run all of these commands by yourself. All you have to do is just drag and drop your files, and it should generate a snapshot. But that's a work in progress, so I'm not going to show that to confuse you more. But this is the tutorial you will need to use depending on what type of knowledge base you have, in which format. Once you have this, we have the snapshot URL that we just copied. Go back to your terminal, and all you have to do is Gaianet config and send the snapshot. Oops, let me copy the URL again. copy download link and paste it. Now, if you want to change the large language model, you can do so by simply passing chat-URL and paste the URL for the large language model. That's all. Now, if you click enter, it will say it is updated from empty to this specific new knowledge base, right? This is a Steve Jobs digital twin agent. You can also try this out on your machines, but the next step to this is customizing this, right? By customization, I mean you have to give instructions to the LLM using the system prompt, right? So you can do the same step where you say Gaia config, or you can edit the file directly. There's no problem with doing that as well. See, if you open the folder, this is what it looks like, right? You can simply open the config.json file and edit it directly in your preferred code editor, right? You can open this up, and once it is open, you can always update the text here, right? In this case, I'm going to say you are a digital twin of Steve Jobs. You can use the AI generated one also. Yeah, it's pretty straightforward. You can just simply save this. Let's go back to our terminal and run Gainet stop and then Gainet init. Since you have changed the values of the knowledge base, it has to download the knowledge base first. So you run the init command. Init is initialization. Once you run it, the next step is to run Gainet start, and now you have a Steve Jobs digital twin. Similarly, we have a bunch of examples. I'll share the QR codes that you can try out using Gaia with different use cases, right? Let's wait for this to complete, and in the meantime, I can probably take some questions if you have any on the chat. Let's see. This is your time to either unmute and ask, or post them in the chat if you prefer that way.
Yeah, I would just like to say thank you for the presentation. I've already got a ton of ideas about how we could integrate this with the agents. So yeah, I'm really looking forward to seeing what the guys do with it.
Awesome. There's more. Like you saw, the init is done. Now the next step is that we've done before, which is just call Gainet start, and they should give the URL. In any of these steps, if you see it stop abruptly without giving you the URL after Gainet start, all you have to do is stop and start again, and it should run. If it doesn't run, that means that you are using a model that is not compatible to your machine. So you have to pick a smaller model. Now, where do you find these models? I already showed you Hugging Face, but we also have a repo on GitHub called Node Configs. The link to this I'll drop into the chat quickly so you can check it out. These are all the configs by default, right, without any knowledge base. If you prefer a knowledge base, we have some examples as well. So let's say you pick you want to run a distill DeepSeek latest Qwen 3.8b model, which released last month. You can simply run this command and it will automatically add the config that is required to download the DeepSeek model, right? So that's one way to also pick which LLMs. Right. So now if you open this, we have the agent that is customized to now behave like Steve Jobs and is trained on Steve Jobs knowledge base, right? You can see system prompt is updated. If you go to the chat with this node and click on chat, this is also updated to the new system prompt. That's how you create interfaces. Now, what you can do after this, right, which is very important. Now you have a chat UI. This can still work, but if you want to build a Telegram bot, or if you want to build a Slack bot using this agent, all you have to do is use one of the agentic frameworks that is available, like Eliza OS or Pydantic or Agno. There are a bunch of frameworks depending on which programming language you know or you prefer or your developers prefer. Pick that and use the API calls simply to call the inference from your specific Gaia node. And remember, this is all running from my machine only. I'm not sending data anywhere. I'm not pushing my knowledge base anywhere. I'm just using my Hugging Face. You can also put the same knowledge base on inside the Gainet folder itself, right? Now that we have the Gaia node, the other concept that I wanted to cover as part of the agenda that I shared is how do you contribute inference and potentially earn points today and token in the future is by joining the protocol, right? Let's say you are running a Llama 3.2 based model. You want to join a domain and contribute inference to it. And for contributing inference, you earn a reward. And if you want to become a domain owner, you can do so by purchasing a domain, and node operators will then join you. You can set rules, right, to to allow people to join your domain. And that's how these are the simple steps in our docs where you decide if you want to become a domain operator and earn some rewards. This is one way. If you cannot run a node today because of your machine or because of any constraints that you have, what we have is public Gaia domains where you can use this as your inference when you're building applications and see how these models respond. Right? We have some specific public nodes that we run or public Gaia domains that we run with Qwen7b, 72b. We also have a Rust coder. You can use this to generate code in Rust. You can also use a generic coder LLM that is trained on CodeStrill, right? You can use this inside your Visual Studio Code or Cursor, depending on which IDE you use. Then this is the place where you can see which all platforms we integrate with, right? As long as OpenAI API works in a use case, you can always replace that with your own Gaia node. So remember that. And then I know you all want more examples, more guides, and more tutorials. We have a bunch of these tutorials here. We also have something called as templates and examples. Templates and examples are plug and play tutorials for you to build these specific use cases, right? Then we also have examples, a bunch of examples. Zerion integration is the one where you can call external API that I talked about to get the most real-time data and display it back to the user, right? All of this data code is available on GitHub for you to plug and play if you are a developer. If you are not a developer but still want to play around with building a node, my recommendation is to use this tool called Flowwise. Flowwise is a no-code builder that lets you drag and drop and build, or you can use Langflow. I don't know how many of you know Langflow. Langflow is also super similar to this tool that you see on the screen, where you can build agents or multi-agent interactions without writing a single line of code, just by dragging and dropping these components and adding your node as your AI inference. Right? I was talking about joining the Gaia protocol. For that, all you have to do is go to for developers and click on joining the Gaia protocol. All you have to do is run GaiaNet info in your terminal, and this will give you two values, node ID and the device ID. Right? You have to take these and go to GaiaNet.ai, which is the website, and click on launch app. This is how you join the Gaia protocol and contribute inference. If you are looking to do that, right? Connect your wallet. Don't worry, no money will go from your wallet as long as you don't sign any transaction for it, right? So once you connect your wallet, just go to domain, right? Here you can launch a domain, or you can also go to node and connect a new node first, right? So to connect a new node, you will need the two pieces of information that I showed before. I'm going to copy and show you how to do this. This is not going to work today because I'm using a model for which I don't believe there is a domain existing, but this is how you join the protocol first, right? You can, once this is done, you can go back to your node and you should see your node contributing inference. And if any of you want to chat with this node, you can do that by going here. I'm dropping the link to this in the chat, and you can see your nodes interaction through the throughput numbers going higher. Now, if you click here, you can join a domain, and once you go to the second step in this, you can pick a domain to join, right? This is where you can see all the domains that are currently available in the network that are available for you to join. If the LLM on your node doesn't match with any of the domains, you will not be able to join that specific domain, or you can still purchase your own domain and launch it. That's how you join the Gaia protocol, right? This is purely for people who are interested in joining the protocol and contribute inference. If you have a spare GPU, or if you want to get some rewards, right? That's the Gaia protocol. Now let's go back to our presentation, and I'm going to talk to you about some of the use cases and examples. So the first example that I have, or the code sample that I have, is PDF to RAM. This example lets you drop in PDFs into the application and instantly chat with it using the node that you're running locally. So I have my node, like we saw, that I'm running locally. You can simply git clone this repo into your local machine, run it, and drop PDFs and ask questions about the PDFs instantly, right? Then there is LangChain integration. If you know LangChain, or if you've used LangChain with OpenAI before, you can use the same and use a Gaia node with LangChain. This is the QR code for that will take you to the Gaia cookbook. We have a cookbook with about 21 examples today, more coming soon. But this is one example that you could use where you can use LangChain and your Gaia node together and build an AI agent on top of it. This is an example that I was talking about where you can learn how to launch a token. This one specifically launches a token on Celo. We also have one example for base chain. All you have to do is when you run this example, it autonomously goes to the AI, which is your Gaia node, and asks it to create a token, a distribution amount of the token, and also a name for the token, and then launches it on the chain fully autonomously. Right? You can see this happening in the terminal. That's the QR for that one. Now, then there is dynamic RAG. Now, this one is a very interesting use case for developers. If you want to build interactions for code bases, this example is where you can see how you can copy paste code bases or just give it a GitHub repo URL and then start chatting with it and get insights about the GitHub repo directly. You can do this fully locally, which means you can have a repo locally and provide it to the repo and chat with your repo. Help it, take it to use, write documentations for your code base, or help generate new code depending on how you write code. That's one example that you can try. All of this is again on your machine. Then there is tool calling. Like I said, if you want to call external APIs, this is a good example where you can get started with how you can call external APIs and get that information and then use the LLM to provide insights or provide responses back to the user. Then there is Telegram bot template. You can use this one to create a Telegram bot. Once you have the node running, you can simply copy the URL and paste it in this example and run it, and you have a Telegram bot up, right? Then you can start chatting with your node inside Telegram. Right? This is that example. Then yesterday, our development team launched Gaia Toolkit, which is where you can learn how to pick which model, right? All in the terminal. So you can say, okay, depending on your machine, it will recommend which models you can run, which is a very easier use case than what I showed you before, where you figure out depending on use case. But here also you have to figure out the better model that you will need depending on your use case. But this one helps you figure out these models or the sizes of the models easily, right? The 3B, 4B numbers that we've seen before, those are the number of parameters that each model is trained on. Then there is Q5, Q4, which is like the compression, right? Imagine if the original picture or a photograph is about 40 MB, if you compress it, it'll become 10 MB without losing much of the quality. Similarly, in LLMs, the concept is called quantization, where they compress the LLM to a certain bits, right? By default, LLMs are either 16-bit or 32-bit. They compress it to a 4-bit, 5-bit, 8-bit, right? Depending on the number, Q4 is smaller than Q8, right? That's again a simplified definition of what Q4, Q5 mean in the large language models naming convention, right? So you can use the Gaia toolkit to run launch nodes easily without having to figure out which model can run on my machine, right? And then this is our Telegram group in the future, post the residency program or during the program itself. If you need help, we have a bunch of developers. This is not a airdrop farming repo. This is only for builders who are building on Gaia. If you're interested, you can come join the repo as well. I'll share the deck, like I said, for all of you to consume later. But now is the time for questions. You can ask any questions that you have. No question is a silly question. I'm happy to answer any questions. I'm glad we covered this in a record amount of time. I know that was a lot of information that I shared. But if you have any questions about any of the specific topics that I covered today, feel free to ask. I'm only looking on this side because your reactions are happening on this side. But my camera is here. But yeah, yes. Somebody unmuted.
I have a logistics question just about so if while the guys are kind of trying this out and implementing it, they run into any issues, do you have a Discord or a Telegram or anything that they can join and ask questions in?
Absolutely. Hold on. This is the Telegram that they can reach out to. Me and my team is always there.
Yeah. Oh, thanks.
And the best way for all of you to figure out how to run AI locally or figure out how all of this works is to try what I shared today. And there is a evil joy in trying and seeing this by yourself, right? I think all of you deserve to experience that.
Yeah, definitely. I think it's so many people got into AI by just running their first model. So it's definitely something to try at least once.
Correct.
Emir, did you have anything you wanted to bring up?
I think I'm also good on my end. What I would like to say is I think Harish, you and the team, you guys did a very good job in terms of, building out the documentation, following us through. I really enjoyed how the steps are very simplified, even for new beginners. It's definitely something to look up to. So I think it's super cool. Like I said, we will post a recording as well. So there's a lot of people that are in different time zones. So if they have any questions, I'll make sure to point them out to you.
Awesome. Yeah. My only bottom line is don't force AI into your use cases or your applications that you're building if there is no need for AI. Right? AI will add unnecessary complications if you do that. So use it only if you absolutely need it. But yeah, happy building. Good luck with the residency program, and I'll be available, and my team will be available to support all of you later during the program if you run into any issues. But thank you so much for joining, and shout out to the team for having me today and allowing me to talk about Gaia to all of you.
Oh, well, thank you for joining.
Yeah, thanks for your time again.
Thanks very much.
Yeah, wishing everyone the best of the day. Like I said, the recordings will be posted, and yeah, if you want, Harish, I'll also add you to the group chat as well, so you can keep up to date with the messages.
Sure, that'll help.
Perfect. Sounds great. See everyone.
Thanks a lot. Bye.